Hello, all. Welcome to our YouTube channel. Today, I'll be discussing how to design 20-watt charger in Simulink. Before going to Simulink, first we'll understand the design part of charger. So, what charger generally does is it will convert 230-volt AC to 5-volt DC to use it for mobile battery charging. So, what all components we have? First of all, we are getting 230-volt AC from AC supply, and then this 230-volt has to be converted to DC using a rectifier. Rectifier will convert 230-volt to around 300 to 325 volt DC. Right, this is the voltage level converted here from rectifier, and then there is a DC-DC converter altogether, high frequency converter and transformer, everything to be together called as a flyback converter, DC to DC converter, where it converts this 300 to 325 volt to 5 volt DC. Okay, this is how this flyback converter is operating to convert this 300 to 325 volt DC to 5 volt DC. Here, first of all, we'll try to simulate a open loop system where you are just converting 230 volt to 5 volt system without any control in output using any feedback system. That is one part. Okay, and we'll try to use directly whatever the modules available in Simscape Electrical. We are not designing each and every component here. We are just using the Simscape Electrical equivalent of this rectifier and together DC-DC converter to get this output 5 volt in our first video. Later we'll be trying to design each and everything, and then we'll try to design a complete charger in Simulink. Okay, let us go to Simulink.
So let us start. To begin with, we need 230 volt AC supply. How to add it? Just select voltage source and then 230 volt. If you are converting it to amplitude, RMS 230 volt to amplitude, it will be 325 volt. It is VRMS into root 2. So we get 325. If you are using Indian AC supply, it is 50 hertz, and then this will be connecting to a DC rectifier. So this rectifier will convert AC to DC. We're connecting 325 volt or 230 volt RMS here, single phase. So it has to be in single phase format. For this, you will just have to use expanded 3-phase ports, which is available in electrical connection. So what it will happen is you will have 3 connections, 3 separate single phase connections, and you can connect to one of the phase. Output will be DC. This will be almost 300 to 325 volt DC will be produced. So this DC voltage will be connected to a rectifier. DC voltage will be connected to a DC-DC converter. You can just browse for a DC-DC converter and you can connect positive to positive and negative to negative of a rectifier to input of DC-DC converter. So once it is done, you can double click on DC-DC converter, just adjust the output settings. You need just 5 volts. We are designing 20 watt converter, so select 20 watt. Output has some ripples, voltage ripple, so connect it to a capacitor. And yeah, higher the value of capacitance, lesser will be the fluctuation. So we'll go in terms of millifarad to have minimal fluctuation. Okay, this is done. And you an electrical reference, a solver configuration. Connect all the negative terminal to this electrical reference and solver configuration. Once you have connected all the solver and the electrical reference, you have to just add a voltage sensor. Connect the voltage sensor to positive of the capacitor and negative to negative end of the capacitor. Then the voltage has to be connected to scope. While you are connecting to scope, you have to add one more block called PS to Simulink converter. So this block you can add. This block has to be compulsory added if you are connecting this voltage to scope, because voltage is a physical value and Simulink scope can understand only Simulink level labels, means it has to have no units. Scope and everything is added. You just need to simulate. Run the simulation button. Once simulation is completed, you can double click on the scope. You can see output is 5 volt, almost stable, but there are still some fluctuation that you can see. It's almost 5 volt, and there might be 0.1 volt fluctuation. Further, this can be improved using filter circuits. This I had showed in block diagram. So this filter circuits can further reduce this voltage fluctuation. And thing is, like, if there are some error that has to be adjusted with the DC-DC converter, this 5 volt has to be adjusted with DC-DC converter. For this, you need to have a closed loop system. That closed loop system can be achieved again with a few of the control system blocks. Further, we'll also go in depth into each module, where we'll talk about rectifier separately, and we'll try to understand rectifier, DC-DC converter, and the feedback path separately, and then we'll try to integrate all of them together to get the charger output. So if you are interested, we'll further continue the series on charger simulations. If you have liked the video, please do like, share and subscribe, and thanks for watching.